Hi everyone, in this video I'll go through chapter 14 on Maxima and Minima to go through the revision set B questions. So let's start with question 1. I'm given a curve here, given by this expression over here, and this curve has one stationary point. Find the value of A and B. So very simply for this curve over here, in order to find a stationary point, we should first find dy over dx first. So let's write this down over here. Okay, for part 1. Okay, dy over dx, since my y is given by a fraction, I can apply the quotient rule. So quotient rule means differentiate numerator first. This will be 6x times x squared plus 2 minus away 3x squared times differentiate denominator, which is 2x. Okay, then the whole thing over here divided by the denominator square, x squared plus 2, the whole thing square. Okay, then I continue to expand and simplify. I should get 6x cubed plus 12x minus 6x cubed over x squared plus 2, the whole thing square. I should get, final answer should be 12x over x squared plus 2, the whole thing square. Okay, so therefore, to find the stationary point, okay, let dy over dx be equals to 0. Therefore, I will get that over here, I will copy this expression. So therefore, I want this expression to be equals to 0. Okay, this is equal to 0. Therefore, by cross multiplying, I'll get 12x equals to 0. X is equal to 0. So that means that the stationary point occurs when x is equal to 0. And I sub in x equals to 0. Sub x equals 0 into the equation of the curve. So therefore, y is equal to 3 times 0 square divided by 0 square plus 2. Okay, and this is also equals to 0, which means that therefore stationary point occurs at 0, 0, and I haven't answered the question yet. Question says find the value of AB. So therefore this means that therefore A equals to 0 and B is equal to 0. Alright, so this is for part 1. Okay, so let's look at part 2 now. Okay, let's maybe I write out over here. Determine whether y is increasing or decreasing for x more than a and x less than a. So let's write this part over here. Okay, over here. Okay, so if I were to analyze this question here, okay, I found that a is equal to 0. So for the first part, okay, part A, when x is strictly greater than 0, I know that over here, okay, 12x is strictly greater than 0. And I know that the denominator of my dy over dx, this thing here, is always x squared plus 2, the whole thing square, is always greater than or equals to 0. Which therefore means that if I divide two positive numbers, I should always get a positive number. This whole expression here, okay, since the numerator, in this case, numerator cannot be 0. So both my numerator and denominator is actually strictly greater than 0. Okay, therefore this fraction here is strictly greater than 0, which means that dy over dx is greater than 0, and therefore y is increasing when x is strictly greater than 0. Okay, and this is for part A. For part B, similar concept. Part B, when x is strictly less than 0, I know that 12x is also strictly less than 0. Okay, since I know that the denominator here, x squared plus 2, the whole thing squared, denominator cannot be 0. This is strictly greater than 0. Okay, because any number square is always greater than or equals to 0. Therefore, a negative number divided by a positive number, this entire expression here, x squared plus 2, the whole thing square, is therefore less than 0, which means that dy over dx is negative. Therefore, y is decreasing when x is less than 0. Is when x is strictly greater than, when x is strictly less than 0. Okay, and this is for part B. Okay. Okay, let me add more square. Oops. Okay, and then from here. Okay, yes. Okay, part C now. Hence state the nature of the stationary point. Okay, so we know that at this stationary point over here, x is let's say at this stationary point, I know that if we were to draw out, this is actually similar to your first derivative test. Okay, x. Okay, if I were to draw out this table so you can visualize. Okay, when x is equal to a, x is less than a, and x is more than a. Okay, my dy over dx. Okay, when x is less than a, dy over dx is less than 0. Okay, so over here, when x is less than 0 or less than a, maybe I should write this as 0 so it's clearer. Okay, instead of a here, the a is 0, x is less than 0, equals 0 and more than 0. This is for part 3. Okay, when x is less than 0, I know that dy over dx is less than 0. When x is equal to 0, I know that this is a stationary point. Dy dx is equal to 0. And when x is strictly greater than 0, my dy over dx is greater than 0. So therefore, this is simply your first derivative test. Sketch of tangent. Okay, I know that this is simply the gradient negative downward sloping graph. This is a horizontal line and upward sloping tangent. Okay, so therefore the conclusion is that therefore 0, 0 is a minimum point. Okay, and this is the answer to part 3. Okay. Okay, and then now the next part says that find the square y over dx square and explain how your answer can be used to justify the solution. Okay, so we can write out the solution here first. For part 4, I know that dy over dx is given by the expression 12x divided by 12x divided by x squared plus 2 the whole thing square. So therefore, d square y over dx square is simply equals to, I differentiate this again using the quotient rule, 12 times x squared plus 2 times square, the whole thing square, minus away, 12x times 2 times x squared plus 2 times 2x. And the whole thing divided by my denominator square, which is x squared plus 2 the whole thing power 4. Okay? So therefore from here you just need to simplify this. So by simplifying this, I should get, by simplifying this, I know that all terms, numerator has terms containing x squared plus 2, x squared plus 2. So I can cancel out one copy of x squared plus 2. I should get 12 times x squared plus 2 minus away for 48x squared, the whole thing over x squared plus 2 the whole thing power 4. Okay, therefore, simplifying everything, 12x squared plus 24 minus 48x squared, the whole thing divided by x squared plus 2 the whole thing power 4. I should get 24 minus 36x squared. Okay, and this is my d square y over dx square. So over here, to make use of my d square y over dx square, sub x equals to 0, my d square y over dx square is equal to 24 minus 0 over 0 plus 2 the whole thing power 4. I will get, this is 24 divided by 8, which is 24 divided by, wait, did I make a mistake? Oh yes, this one here should be, I cancel out the x squared plus 2, so this one should be 3. sorry for this error. This part here should be 3 power 3 power 3. Okay, so over here, this should be 2, the holding power 3. 24 divided by 8 should be equals to 3. And this is greater than 0. So therefore, by second derivative test, 0, comma 0 is a minimum point. So there you have it. We have two different ways using either the first derivative test or the second derivative test to show that a is 0, comma 0 is a minimum point. Okay. Alright, so now let's look at part question 2 now. Okay, question 2 is a really test of your understanding of what does the dy over dx and d square y over dx square mean. Okay, so let's look at part 1. I'm given this graph of f prime x, or in case you find this unfamiliar, this is the equivalent to dy over dx, but instead of y, my function is now fx. And f prime prime x is d square y over dx square. Okay, so for part 1, okay, say the x coordinates of the stationary point of the graph of y equals to fx. So I know that for stationary point, we go back to our conceptual understanding. For stationary point, dy over dx is equal to 0, or f prime x should be equals to 0. So basically, to solve this part here, I just need to look at my f prime x graph if I find the x-intercept. Okay, so over here, simply based on this graph over here, the x-intercepts are A, B, and C. So for part 1 is simply, therefore x is equal to A, B, and C. Okay, this is for part 1. Okay. Part 2, determine the nature of the stationary point. So we know that my f prime x graph, whenever my f prime x reaches 0, this is a stationary point. How do I determine the nature of the stationary point? So let's analyze the first part. Okay. Let's try this start by start. When x is equal to A, okay, we analyze the graph. This part of the graph over here, I highlight in this part. Okay, this is a stationary point. Maybe I can highlight this part here. This is a stationary point. Okay, B is also a stationary point. I look at this f prime x. Before it reaches x equals to A, this is negative. After x is more than A, this becomes positive. So if I were to sketch this graph, it means that this portion here, the gradient is negative at first. Reach point A, gradient becomes 0. After point A, gradient becomes positive. Therefore, over here, we can say that, therefore, when x is equal to A, stationary point is a minimum point. Okay, we can do the same for next one. Okay, when x is equal to B, I analyze this part of the graph now. Okay, this is my f prime x graph. When x is equal to B, before B, this is a positive f prime x. After x is equal to B, it becomes a negative f prime x. So therefore, this means that if I were to sketch this out, this means that at first the gradient is positive, which point B become gradient of tangent becomes 0. After point B, the tangent become negative gradient. Therefore, this tells us that when s is equal to B, stationary point is a maximum point. Okay. And if we follow the same concept for point C over here, point C, gradient become from negative, gradient becomes 0, then become positive gradient. Okay. Negative gradient to become positive gradient, same as this part here. This is a minimum point. So therefore, when x is equal to C, okay, stationary point is a minimum point. Minimum point. Okay, and this is for part 2. Alright, so let's now look at part 3. Find the intervals for which fx is decreasing. For fx to be decreasing, let's write out so that we understand. For fx to be decreasing, it is like saying for y to be decreasing, we know that dy over dx is less than 0. For fx to be decreasing, f prime x must be less than 0. So I analyze this graph of f prime x. I just need to find for this graph over here, which part of the graph is less than 0, which is below your x-axis. I notice it is this part here highlighted in red. So therefore, for fx to be decreasing, f prime x is less than 0. The parts of the graph is x is less than a, or x is between b and c. So therefore, answer is simply x is less than a, or x is between b and c. Okay. And then the next part, it becomes a bit more challenging, but the concept is still the same. For f prime x to be increasing, same concept. Now instead of fx, it becomes f prime x. For my f prime x to be increasing, it means that my f prime x, the gradient function of this gradient f prime x, should be more than 0. So I look at this graph over here, f prime x graph. I want this portion of the graph to be more than 0. If I were to highlight, it is simply this portion of the graph. So therefore, answer to this question, simply x must be strictly less than negative p, or x is more than p. Okay, and with that, I've solved question 2 from here. Okay, let's move on. Question 3 here. This question is in worksheet. Oh, I will not go through your solutions. Can be found in your worksheet. We have done this in class before. Okay, I will move on to question 4 now. Question 4. Okay, I am given this spherical ball of radius 6 cm placed inside a cone of height h cm, radius r cm. Okay, so over here, what can I do to okay, let's analyze this. Okay, usually for this type of question, right, you need to make use of common concepts like, for example, similar triangles. So very simply, right, let's analyze this. Okay, let's see if you can spot any pair of similar triangles. Okay, so over here, by analyzing this, I can see that I know that this height here, let's label this. This height over here is h. Okay, and let's see, over here, the radius of this circle is 6 cm. Okay, okay, so you can see that actually, right, this, I can spot a pair of similar triangles. This is a, let me highlight, this is a common angle between, maybe I put in one color, maybe I choose, okay, this triangle here I highlight in orange color. Okay, one triangle 1. Triangle 2 is this bigger triangle over here. Okay, I hope that you can see that these two triangles are similar. Why are they similar? Common angle, you know, your similar triangles, you should have your AA similarity test. I know that both triangles have a right angle and they both share a common angle. Therefore, these two triangles are similar. Okay, so but how do I find out the length of these triangles here? I know that since this circle here, okay, the radius is 6 cm, which means this is the center of the circle, which means that this distance here is 6 cm. Therefore, for this orange triangle here, this length here is simply h minus 6. Okay. So therefore, if I were to compare from here, okay, bisimilar triangle, I know that maybe I can highlight. Okay, let me erase this so you can see. Oops. Okay, okay. Okay, so if I were to check, right, over here, this RCM matches with this base 6cm over here. Okay, and this H, how do I use a blue highlighter. This H over here actually matches by similar triangles with this length of the triangle over here. Okay, so therefore I know that for this orange triangle, this triangle here, this length over here can be found by Pythagoras theorem. This length here is simply square root of h minus 6 the whole thing square minus 6 square. Okay, so therefore over here, if I were to use similar triangles, bisimilar triangles, okay, I know that let's say r over h of the big triangle, okay, is simply equals to 6 over square root of h minus 6 square minus 6 square. Okay, then from here it's just simplification and manipulation. Okay, from here I will get my r is simply equals to 6h over, I simplify my denominator. Okay, so it's a bit, h square minus 12h plus 36 minus 36. Okay, r is simply equals to 6h over square root of h square minus 12h. Okay, so therefore if I were to look at the volume of this cone here, V, I know that volume of cone is simply 1 over third pi r square h. Okay, and I want to turn, based on this, to show this part here, I don't have any more r. So therefore, I will replace my r by this expression I found in using similar triangles. V is equal to 1/3 pi times 6h over square root of h square minus 12h, the whole thing square times h. So this is 1/3 pi times 36h square over h square minus 12h times h. Okay, therefore I simplify everything, I should get 12 pi h square, h can cancel out from the denominator the terms, h minus 12. Okay, and I've shown for part 1. Okay, so then now moving from here, show that find, given that h can vary, h is a variable now, find the value of h such as v as a stationary value. So for this to have a stationary value, it means that dv over dh must be equal to 0. So very simply over here, part 2, given that v is equal to this, dv over dh, I can now find by differentiating my volume expression. So differentiate this is simply 24 pi h times h minus 12 minus away 12 pi h squared times 1. Okay, then the whole thing divided by denominator square, which is h minus 12 the whole thing squared. Okay, then I simplify everything, I should get maybe I can factorize out 12 pi h. I should get h minus 24 okay, then from here I continue to simplify. Okay, h minus 12 the whole thing square. Okay, so from here then we can, to find the stationary value of v, we will let dv over dh be equals to 0. Okay, Okay, wait, actually let me just expand this step by step so that I can verify. Okay, so 24 pi h square minus away 12 times 24. Okay. Okay, minus away 288 pi h minus 12 pi h square. The whole thing over h minus 12 square. Okay, then I continue to then I can simplify and factorize. This is equal to 12 pi h square minus 288 pi h. Yep, then I factorize out, I should get this m expression here. Okay, so from here, okay. So to find stationary value of v, I let dv over dh be equals to 0. Okay, then after that, I will solve this equation. So over here, 12 pi h times h minus 24, the whole thing over h minus 12 square equals to 0. Therefore, 12 pi h times h minus 24 is equal to 0. Therefore, h times h minus 24 equals to 0. I will set h equals to 0 or h equals to 24. Then I'll reject h equals to 0 as I know that h must be strictly greater than 0. And I'll get the solution here. Okay. Okay, so for the last part here, find the stationary value of v and determine whether this value is a maximum or minimum. Is very simply over here. I will quickly run through this part. Part 3 here. Okay. Part 3 here. Sub h equals to 24 into v. And my v is simply 12 pi times 24 square. The whole thing divided by 24 minus 12. I should get my final answer, which is 576 pi. Okay, and I round off to 3SF. This is simply 1810. What's the unit here? This is cm. So this is 1810 cm cubed, round off to 3SF. Okay, and then the next part is to determine whether it's maximum or minimum. So you can either use your first derivative test by, I will not show the working here, but you can either use first or second derivative test. You must show the workings clearly. Okay, derivative test. Okay, you will show that, therefore, v is a minimum value. Okay, and that will be this for question number 4. Alright, okay, let's look at the last question for today. Last question here. This question here is relatively straightforward. It might be a bit complicated, but actually the steps are rather okay one. So very simply, this question here says this is an open cardboard box with a rectangular base and a closed fitting cardboard lid. Okay, so over here, what we need to do is simply, I need to combine the total area of the cardboard so I can see that I will do it step by step. Okay. Part 1. Okay. We start by finding the total area of cardboard used to make box and lid is 3000. I do it step by step. Total area of lid. Okay. Based on this diagram over here, the total area is simply 2 times 2x times 4 plus 2 times x times 4 plus 2x times x. 2x times x. Because this is an open cupboard. Okay? Therefore, simplify everything, you should get 24x plus 2x squared. Next part. Total area of box. Okay, this is simply equals to 2 times 2x times y plus 2 times x times y plus 2x times x. Since this is an open cupboard, okay, for the box as well, simplify everything, I should get 24x plus 6xy plus 4x squared. Okay, Therefore, I know that since the total area of the cupboard is 3000, therefore, this means that from here, okay, total area used is simply equals to, I add everything together, I should get, sorry, did I calculate wrongly? This one, this one should be, total area of box should be 6xy, yes, plus 2x squared. Okay, so therefore total area of the cupboard is simply, I add everything together, I should get 24x plus 6xy plus 4x squared. Okay, so the question tells us that the total area used is 3000 cm square. So therefore I know that, therefore 24x plus 6xy plus 4x squared, this whole thing is equal to 3000. Okay, therefore if I were to find an expression for y in terms of x, so therefore if I were to make y the subject, y is simply equals to, we do it step by step. Okay, maybe I write it step by step. Okay, so over here, 6xy is equal to 3000 minus 24x minus 4x squared. Therefore, y is simply equals to 500 divided by x, everything divided by 6x, minus 2 over 3x minus 4. Okay. Okay, let me rearrange the terms so it's clear for you. Okay, yeah. If I divide everything by 6x, I will get this expression. Okay, so therefore, for part 1, given that, to show that the total volume of the box is given by this expression here, I know that volume of the box is simply, based on this expression here, 2x times x times y. Okay, so over here, this is 2x times x times y. This is equal to 2x squared y. And I replace now by y by this expression that we have found. So over here, this entire thing here. Okay. Okay. Therefore, my volume, I'll get 1000 x minus 4 over 3 x power 3. Okay. Then minus 8x squared. Okay. And that will be for part 1. Okay. So I know that my volume V is given by this expression here. This is for part 2 now. Find the maximum value of V. So the steps are the same now. To find maximum value of V, I must find a stationary value of V first. dV over dx is simply differentiating my V. I will get 1000 minus 4x squared minus 16x. Okay. Then to find maximum value, we let dV over dx be equals to 0. I will get negative 4x squared minus 16x plus 1000 equals to 0. I will get this quadratic equation, x squared plus 4x minus 250 is equal to 0. Okay, let me extend this. So from here, once I get this quadratic equation, very simple, use our quadratic formula to find the value of x. X is equal to negative b plus minus square root b squared minus 4ac, 4 squared minus 4 times 1 times negative 250. Okay, then this whole thing divided by 2a. Okay, x is therefore equals to, simplify everything, negative 4 plus minus square root. Evaluate this square root, I should get 1016. The whole thing divided by 2. Okay. Then you should get 2 answers from here. Okay, I should get, if I put it as 5SF for S intermediate working, 13.937 or negative 17.937, and I reject x being a negative value since x is always strictly positive. Okay, Then now once I found the value of x, to show that this is shows a maximum value, I can use the second derivative test since this is quite easy to differentiate. D square v over dx square is simply equals to negative 8x minus 16. Okay, so therefore I sub in when x is equal to 13.937, d square v over dx square is equal to negative 8 times 13.937 minus 16. Okay, I'll get negative 127.496, which is less than 0. Therefore, by second derivative test, okay, by the second derivative test, x equals to 13.9 gives the maximum volume. And with that, I've answered question 5. Yes, question 5. Okay, so I hope that you are able to learn something through these questions from this revision set. Okay, and that's the end of this video.